All right, an assumption you can make whenever you're doing calorimetry and you're putting a piece of metal in a solution, whether it be water or some other kind of solution, is that whatever heat is lost by the metal will be gained by the water. And so what we can generally do is set the Q of the metal, the heat of the metal, equal to the heat gained by the water. And since Q equals MCAT, we can simply write it as MCAT for the metal equals MCAT for the water. What you can do at that point is you can just simply plug in. We know our mass of the metal is 59.047 grams. We don't know the specific heat of the metal, so we leave it as C, or you could insert an X there. And my change in temperature for the metal, well, the metal started at 100 degrees, it was heated that high, and then the final temperature of the water-metal mixture was 27.8. So my change in temperature for the metal is 72.2 degrees Celsius. I set that equal to water. So the MCAT for water is the mass of water is 100 grams, assuming 1 gram per milliliter. We know the specific heat of water is 4.18 joules per grams degrees Celsius. And my change in temperature for the water, since it only went from 23.7 to 27.8, is 4.1. Our final step is simple algebra. We want to isolate C, so we divide both sides by our 59.047 times our 72.2. Just take care that when you're plugging it into your calculator, 100 times 4.18 times 4.1 divided by your 59.047 times 72.2. Just make sure that bottom part is in parentheses. Once I plug that in, I'll have the specific heat for the metal. When I do that, I get a specific heat of 0.402, and then the unit for my specific heat is joules per gram, and then degrees Celsius. And that's my final answer.